Thank you everyone for coming to this session about cloud workspaces in OpenShift IO. Hopefully everybody saw the keynote earlier. So I'm not going to spend too much time talking about what OpenShift IO is. I think we're going to go fairly quickly into how the workspaces work, some of the capabilities they have. So Gorkem is going to help me with a lot of the demos. But before we do that, I'm just going to talk a little bit about kind of what the workspaces are, how Eclipse Che fits in, and why we think this is, why we chose this as the technology to use for the code editing piece, and why we think it's important. So, I said I won't talk too much about OpenShift.io, but just sort of in this diagram to orientate ourselves, we're kind of in that create phase, right? So you've worked out what it is you want to do, you've worked out how you're going to do it, and now you're sort of sitting down and getting started on the coding. So you're going to be doing a lot of coding, obviously, lots of testing, lots of debugging, a lot of iteration. My experience, as a developer has always been that I guess this is the bit I enjoy the most of developing, is kind of this bit where you're creating something new and you're solving challenging architectural problems. I guess it's probably also the most frustrating in some ways, because you're like, why won't this damn thing work? And you're constantly changing and changing. And so that's, I think, quite a lot of what we're going to show you today, is how Che can help you with some of those problems. So I think I'm going to spend maybe 5-10 minutes talking about what a cloud workspace is. We started to touch on this in some questions earlier, actually, but I'm going to try and give you an idea of how this actually works. So the first thing I think that's really important to talk about is this idea of a stack. So one of the things that I think as a software developer is most frustrating is you need to get started with something and you don't know where to start. So you kind of pull some bits together and put them in a project and get going. And then you build something and you show it to your boss or whatever, and they say, oh, that looks good. Now how can we use this? And then you're like, oh, no, this is a whole new class of problem. I've now built this random assortment of bits on my desktop, and I need to actually get this running in a place where other people can view it. So one of the things that we felt this was one of the kind of the fundamentally broken pieces of software development today, this idea that you start by building something on your laptop with no real thought about how this is going to run in production. And we thought that containers are a real kind of game changer for a developer from this perspective, because they allow you as a developer to easily say, from day one, this is the environment that I'm going to run for development and for production. And you get that reproducibility all the way through. So Todd showed you earlier in the keynote using a Vertex stack. We also support Spring Boot and Node. And because the cloud workspaces are all based on Eclipse Che, we have a lot more opportunities upstream to bring more stuff in. So I think Gorkem later is going to show you using a Node workspace in Eclipse Che. But Eclipse Che also has support for things like C# and Python.
Yeah, Python.
Yep. What else? So you've got your stack, but what do we do next to kind of change this from being just a Docker container into a workspace? So the main thing that kind of Che adds for you, the workspaces add for you, is a whole set of tools that kind of get, for want of a better word, injected into the container. So these include things like compilers, so Java-C, build agents. Build agents enable you to run things like Maven builds. Diagnostic tools, so this could be things like syntax errors, or missing imports in your code. You get content assist, so the ability to kind of explore the API of your classes and understand what's going on. You get rich quick assist, so renames, import organization, debugging. So Che, for example, will support the Java debug protocol. It also supports GDB, so if you're doing C development, you can use GDB. And then, of course, the final thing you get is the ability to run tests, so the ability to right-click on something and say run this as a test. And again, Gorkem will talk a bit about the extensibility later on, but this is actually built as a fully extensible system. So one of the things we've shown you is the ability to run the OpenShift analytics right inside the editor, and that's built as an extension, and built using the same kind of approach of taking that base container and injecting what we need in. So now you've got a stack, and you've got some tools so you can work on work with the stack. But the next thing you need is obviously your code, right? You can't do anything without any code. This is pretty useless. So I'm pretty sure everyone who's here is aware that Red Hat has been a long-time supporter of Git and a big fan of Git. You know, OpenShift has been heavily based around Git, and we've continued doing that. So we integrate with GitHub, but we also plan to support other Git options fairly soon, right? So right now we're pretty much tied to GitHub, but you know, all of these technologies just support generic Git. And we go kind of further, right? One of the things we wanted to do with OpenShift IO was not just provide you with a set of tools, but actually provide you with an integrated set of tools. And this means that when you sign in to OpenShift IO for the first time, one of the things it asks you for is permission to act against your GitHub repo, permission to act against OpenShift Online. And we use that to automatically provision Che with your Git credentials, with your, you know, all of your details, so that you can just go ahead and start committing. You don't have to worry about how you configure things. Let me talk a little bit more about the benefits of running in a container. So I think that, you know, I don't know if you guys are like me, but I tend to have a lot of different repositories open or code on my computer. You know, I looked, and James says that Fabricate has 200 and something Git repos. I was looking at my GitHub org, and I have like 150 repos in my GitHub or something like that. I typically have hundreds of projects on my disk. I lose track of what's where. You know, if I'm using a shared Maven repo, then I get conflicts and errors and all sorts of things creeping in. Or I'm using isolated NPM repos, and then I just don't have any hard disk left, because it's all just packages and dependencies. And I think that this is something else that, you know, I would really love to see as a much more isolated way in which to do development, a way where each project can really run in its own isolated space. And that's what Che gives you, because each workspace is actually a container, an isolated container that's running and fully isolated from every other workspace that you're using. So I think you finally actually have that ability to really isolate out each workspace. And then if it's not working, tear it down, throw it away, and just recreate it. There's no more of that, oh, well, this doesn't work anymore, so maybe I have to reinstall Windows or reinstall my operating at this point, because nothing is really working for me anymore. Another great point about these cloud workspaces, and actually I ran into it earlier. This is my Surface, and it doesn't work with this projector for some unknown reason. And so rather than panicking and not being able to do the demo, I was just able to take the laptop that was in here, log into it using my credentials, and immediately access the development environment I was in. What we do is we give each workspace a unique ID, and you can actually just take that unique ID with you, revisit it at a later date from another computer. Todd has this working on his phone, for example, and you can just go in there and access exactly where you were. And it's not just that it remembers what's in the workspace. It will also remember what files were open, where the cursor was in the files. So you go back, and your cursor is back in the place it was where you last left it.
Your debugger is connected. Yep. If you had a debugger running, it's still connected. You're still in the same point where you were debugging.
So, you know, I think one of my main focuses at the moment is having a break from my job. So I'm looking forward to my vacation, which starts on Friday after Summit. And so this is something that was, you know, really hard in my mind when I was putting this presentation together. But, you know, I think it's great that, you know, I can go away and I can come back and I just visit a URL and everything is back where it was when I left. There's no, like, oh, well, no, I'll use my laptop for something else whilst I was away, or things didn't quite work out. You can just go away and come back, and everything is exactly where it was. So I think this sounds great. I don't know what everybody else thinks, but I love this idea. I mean, for me, the inspiration for a lot of this for me was, I thought I couldn't see, about 5 years ago, we really started using Google Docs really heavily. And I am now so reliant on Google Docs that I could not do anything else. I love the collaboration features. I love the fact that I can interact with other people. I can be talking to Gorkem on the phone, and we can see what we're doing on the screen as well at the same time. And you know, when I look back, there is no way that I could have thought 7, 8 years ago that I would be using Google Docs for everything. That would just, and it blew my mind that we had gone from a world where this was not going to be possible to I could actually just rely on this for everything I do. And I think that the same has to be true of development. We have to get ourselves into that position where we can really collaborate much better, where we can have those features that I love in Google Docs. So the challenge, I think, though, is that, and the reason I bring up the Google Docs analogy is because it is very true there as well. I think that you think, well, there's no way I can stop using PowerPoint or Keynote or Word or whatever it is you use because I need this feature and I need this feature and I need that feature and I need this feature, and it does, this other thing does not have it. So I think that for me, one of the essential points of any IDE, in fact, any development system, is the fact that it is extensible. And that's one of the great things that Che offers, and the cloud workspaces offer, is the extensibility. So we have kind of two extensibility points in Che. So first of all, you can build workspace agents. Workspace agents allow you to operate kind of on the back end almost, right? Yeah. So that you can do things like you could build build tools, so the Maven integration. You could build a linter to check your code. You could do code analyzers like the Bayesian, the Fabricate Analytics language server protocol, which Gorkem's going to talk about in more detail. You can also build GUI plugins. And these are things that really just sit in the browser and interact in the browser. So a good example of a GUI plugin, if you wanted to build something that may be called a REST endpoint, maybe you saw Todd's demo earlier and you thought, well, it's great that he's showing the JSON being output in the browser, but I really want to, pretty print that out and have a nice dialog that shows that. That's a good example of a GUI plugin. But I think that's probably enough of me talking away. So I'm going to hand over to Gorkem, who's going to take you through some of the things that I've just been talking about in a lot of detail and show you them, I think, more importantly.
Yeah, let me just mirror so that I can see what I'm looking at. All right. The first thing that I want to show is to how we create a workspace, how we manage our code, how we start from. Let me get back to my trading sites. So the first thing that we do is if we want to create a new code base, we just start from our stack selection, and we select a stack for ourselves. As Pete said, we support various stacks like Vertex and Spring Boot. Node.js is on its way. So we start from there, and let me just, it's not going to like this name. And then we select our pipelines and all the other details that we are going to have to select. And when we click Finish, what it does for us is it actually creates us a repository that we can import into our workspace. So I'm not going to go through those steps because I'm clumsy. I'll just move to my workspace that I have created and hopefully running somewhere. Yeah. So this is the workspace that I have created. So I want to show you that the working with this workspace experience is very close to what you might expect when you are working on a. Is this too small?
Yes.
Yeah. That's easy to fix. If I can find the. Is this better? Okay, so it's very close to what you would get with a regular desktop IDE, right? So you do your control click, and it does you gives you code assist, and you go here, and let's say that I don't like this name to be a local variable. I want to change that to a field. You do this, convert it to a field. And it is now converted somewhere. If I can click it. Yeah, sorry, this. Just let me. Yeah, it's right there, but for some reason it didn't refresh quick enough. So it just does the refactoring for you, as you would expect with a regular IDE. And the next thing that you can do is, of course, we have commands here that you can run on the workspace. Let me quickly show you different kinds of commands. For instance, you can do a Maven build. It will just run the Maven build, whatever your Maven build target is. You can actually modify those. Or you can add your different versions of your application, different commands for your application. Let me just first try a debug run. So I'm going to do a debug run because I want to show you the debugger. That's one thing that you always use, right? So now what happened is it actually did compile my Vertex application, and then that started running on Vertex debug mode. What Vertex debug mode does is by default it opens up the debug port for the JVM at 5005, but you can configure that. And what I'm going to do next is to show you how we set a breakpoint somewhere around here. So next, let's go back to our terminal, and I'm going to just do a curl here. Once I have for some reason it just doesn't cooperate with me. Let me just refresh my browser. All right. Yep. So that's as easy as hitting refresh to recover sperm, something like that. What's API? Greeting. And when I want to see this. When I hit this, it's going to, the debugger we need to start the debugger now. Let's start the debugger. So as I said, the debugger is running on 5005, so it's connected to the debugger. So when I go back to my terminal and hit the API, the debugger will stop on that line. And what I can do with it is, of course, I can see the values of it. Let me just go over it, and you can see that the name has the value world. But let's say that we don't like that to be world. We want to change that to something else, so we can do that. Let's change it. And when I resume, on the terminal, I should say, see hello summit. So as you can see, this provides you all the tools that you need to run, build your application. You have a debugger, code assist, several ways of running the commands, access to the terminal that is running on the workspace. So how does this all look in a more logical sense? So where does all these other small pieces fit? So the whole thing actually starts from the code bases screen that you have seen. So the code bases screen actually talks with a API that is running on the Che server, and actually gives the details of your code, your stack that you have chosen, and all that, which creates your workspace. And when creating the workspace, it actually takes care of details like routes, different, if you have multiple containers that needs to be created as part of your workspace, it takes care of that as well. So your workspace is actually a good approximation, not even approximation, a good duplicate of what you would have on production with your IDE and other tools that would inject it to it. And once it's done, it opens up a browser. And you see the IDE there, the HTML, CSS, JavaScript-based IDE, which starts talking with another set of APIs, which you see there as WS agent APIs. Basically, these APIs just talk with the small agents that we have just talked about, like the stuff that you can actually extend. If you want a C++ debugger, you can just add an agent to a workspace, and the WS agent will get aware of it and start talking with it. And this all, as you expected, runs on OpenShift. And next. slide. Yeah. So, and if you go into a bit more detail on how this is actually physically laid out on OpenShift.io right now, is we have 2 pods that are running Che. When you start running Che, we have a pod called Che host, which actually includes the Che server. And every workspace that you started is started as a pod, and you will see them, if you have 10 workspaces, you will have 10 pods. And these are all packaged into an OpenShift project. And they are running on OpenShift Online nodes, with each node has 16 gigabytes of RAM. And we use 2 persistent volumes backed up by Amazon EBS. One is always mounted to a workspace, and the second one is always mounted to your server. So this way you would never lose data, because it's a persistent volume, and your data is persisted that way. And one thing that is done, very interesting, that I'll show it on the next demo, is when you select a stack, if your stack exposes ports and so on and so forth, we actually just take a look at it and say that, oh, this exposes these ports, so they may use it for testing. So we actually create routes for you, so that you can reach to your pod when you're testing it. I'm going to show an example of it. It will, it's one of the good features of it. Oh, we did the debugging. All right. And we can move to Node.js. So this is another workspace that I'm running. The reason that this is different, this is actually running locally. So this is actually running on my, if you're familiar with Container Development Kit, it's actually a local copy of OpenShift running in your local machine. This is actually running on Container CDK, Container Development Kit. The reason for that is we haven't yet fully released the Node.js containers to OpenShift.io. But I want to show a quick demo of what is coming there. So this is your regular JavaScript. As you can see, you can still get linter support on the editor. We also get, well, with JavaScript, it's always a bit shady, but you also get code assist for your JavaScript code. And what you can do is, since this is a Node application, what I'm going to do is you can actually, with the help of the commands, just build it and run it. So I'm going to just run it. This is a Node Express application. So this is now running and listening on port 3000. It already reported that. But one thing to note here is this link over here that says preview. This is the routes that I have talked about. So what it did is it realizes that, oh, you're exposing port 3000. I need to create a route for you so that you can reach to it. So when I actually click to this, it will just go to this test application, which just retrieves my timeline from Twitter, and you can just do your testing directly on the cloud. So let's go back to the analytics. We talked about, you have seen it on the keynote demo that when Todd did it, right? There was a logging API that had a security issue. Well, it turns out that commons file upload has a version that does have the similar issue. So what this one is, and we talked about the agents earlier, the workspace agents. So what we built is actually a workspace agent that is integrated as a language server. So it's a language server that integrates with Che and gets notification of all the code changes and do its analysis, which you will be able to hear in 2 sessions from now, and then and gives you a error marker so that you can fix it before even doing your commit. So yeah, let me go back, fix it. And I want to tell actually a bit more about language servers because it's a very important part of what we do with our integration. So the language servers is the architecture that we are using for building APIs that serve a single purpose. So they are more like microservices for your IDE. We use JSON RPC to talk between the server and the language, and the lifecycle is managed by the tool. So in this case, it's actually the workspace that is managing the language server. But the workspace decides whether it needs the services of the language service. Like if you open a POM XML, the workspace understands that and says, oh, okay, there's a POM XML open. Now I need to start the analysis language server. And the language that is spoken between the tool and the server is actually called language server protocol. It's an open protocol, open source protocol. And the funny thing is it actually has its roots from Microsoft Visual Studio Code. It's something that we started collaborating a year ago on that protocol. And we have several implementations of language servers. And we have several integrations on, for instance, Che, Vim. We have VS Code, Java stuff that we have implemented and became really popular. What else we have? We have Atom now implementing language server protocol. So the benefit is all these language server protocols you can pretty much take and package for Che and use on your workspaces.
Thank you, Gorkem. So, I don't want to spend too much time talking about what we think should come next. I kind of wanted to get to some questions. I think what time are we at? Yeah, we're kind of coming up on question time as well, so that's great. But some ideas that we had. So what we've shown you so far is kind of single container workspaces where you get a single container and you can use it, which is good. You can build your app in that and it works pretty well. But we all know that real apps often have databases or often have caching stores or often have all sorts of other things that go alongside them. And actually being able to pull that whole kind of pod of stuff into your Che editor and being able to run that section of your that microservice with all of its dependencies inside Che is going to really, I think, increase the power of what we can do. So adding that into OpenShift.io is definitely something we're considering. I think there was a good question in the previous session about can I build custom stacks. So that's something that Che supports. We don't quite support that in OpenShift.io yet.
We need to tweak that for OpenShift.
We need to tweak the UX and things like that just to make that easy to access. But stacks are written, in a JSON language?
It can be a Docker file. It can just be a reference to an image.
And then you can kind of configure what you want. Gorkem showed you the commands. You can configure custom commands, and so you can pre-configure everything like that. I talked about the fact that one of the things that gets me excited about this is the ability to collaborate, right? The fact that you've actually got this in a web browser, you've got a URL, and everybody in this room has a web browser. I'd be amazed if no one in this room doesn't have a web browser. So all you have to do is you visit this URL, and you are working and you're collaborating immediately. So, there are some great features again in Che that really support this, and we want to bring those down.
Yeah, we will be bringing those in. Like you can collaborate in such a way that you share the workspace, or you can actually just send a copy of it, and they will just have a copy of it for a temporary time, which will be cleaned later. So those sort of sharing scenarios will be there. Yeah.
And then as Gorkem showed you, Node support, .NET support. Again, I think this is an area where feedback is really helpful to us. A lot of us come from a Java background, so that was where we wanted to start. But this, as Todd said earlier, is not just about Java. It's about all of these languages. So getting feedback about that. But honestly, getting feedback about what you guys think of Che, whether you think it's a good fit, whether you think you would like to use it, where you think we should go next. I think that's kind of what I would like to understand from this room, at least. So with that, I think we would like to say thank you and open it up to questions. So yeah, the question is, does collaborate include pairing?
So right now, no. You mean multiple people editing the same file and seeing the changes simultaneously? So we are not supporting that, but we are working on it.
And it does kind of work today. I mean, you can do it, but it's not a brilliant experience because sometimes the changes take a little bit of time to show up and things like that.
Yeah,
So we need to improve the kind of the real-time experience of it, I think.
Yeah,
and I don't know how we deal with.
It was visible on the demo as well. There was one moment where browser lost the synchronization.
Yeah.
So we need to overcome issues like that, but yeah.
I think that's a really exciting potential with this, right? So that's one of the things that gets me.
You said you had a workspace per pod, and you had a 16 gigabyte server. How many workspaces are you going to be able to support?
Yep. So the question is, we currently put a workspace in a pod, and we use nodes that have 16 gigabytes. So and how many workspaces are we going to support? So let me kind of give you two angles on that. So first of all, you can have multiple pods per node. So in fact, Gorkem said it's 16 gigabytes per node. That 16 gigabytes can be running multiple pods. It can run multiple users on the same node. It depends how you configure your quotas and your limits on the system. The 16, so I think at the moment we run 3 or 4, we're aiming to run 3 or 4 users per node. And that would include the Jenkins and the Che and the builds and the containers you're running, et cetera, et cetera. Where was I? Yes, that was part of it. So, it's kind of the pod, one of the great things about the OpenShift structure is it's very flexible in terms of how you schedule things onto particular nodes and how you structure your nodes. And then what we do in terms of the workspaces is on OpenShift IO, what we do is we allow you to have running one workspace at any time. But what we can do is we can, passivate or idle or something like that, the workspace. And what that means is because we have the persistent volume backed by the EBS storage behind it, we can take the workspace down, save it to disk, bring another one up, and then when you want the previous one, you can request it. It will take the one that you currently have up, down again, and bring that one back up again. And that operation takes, I think, around...
No, that is a very quick operation. It's just reviving the snapshot image.
So one last thing to add on that is we will eventually also supply support for OpenShift online save and overseas, where you can then run multiple environments and configure if you like. So in the free tier, we're going to give you a certain amount, and you can always just say, I want to run an OT or a OpenShift page if you like. That'll come later in the year.
So to support like 1,000 users, you need 300 plus.
The numbers are, we're working on the numbers. So, right now, I can't remember how much exactly we allocate right now to make it work. But I mean, at the end of the day, remember that each developer would have, 8 or 16 gig of RAM in their desktop, and this stuff unfortunately does take memory. There's no way around that. So we are looking at better strategies, so, trying to multiplex things better, understanding, for example, that most people don't work 24 hours a day, 7 days a week. They probably work 8 hours a day, so yes, okay, we can get 3 active users on a node, let's say, but actually you probably can get 9 users if you go around the world, and we can do a lot of tricks like that to hopefully improve the way things work, being able to take stuff down, idle stuff out.
Around 10 minutes, the workspace idles itself.
Until we have a 300 node cluster at hand, can we use the CDK to give the same experience to local developers? So we use their boxes?
That's an interesting question. That's a question that I have received earlier. Can I just take my the OpenShift IO or Che and run it locally? Yes, you can. It takes a bit of work right now, but that's one experience that we want to polish so that it is seamless for anyone. We've been getting a lot of requests for that. Something.
So we've built this as a sort of hosted service, and our management tools work on the hosted world. I think there are kind of 2 main connection points where you can make this a more local experience today. So one is through your Git repo, right? You can just check out your source code and run Che on Minishift or run Eclipse or IntelliJ or whatever and work on the same source code, commit it back and collaborate that way. The other one is through the Docker container registry. So again, you can kind of pull this out at a binary point. Mm-hmm. We also do want to work kind of on the roadmap is to work on better integration for local tools, whether that's Che running locally in Minishift and just being able to kind of push the workspaces or pull the workspaces around. But that's not something we kind of directly support yet. You probably could make it work, but we haven't put any time into that. I don't know how easy or difficult it would actually be to make it work.
It needs to be a good experience. So.
Yep.
I just want to make sure that it's important, especially for our audience like we are. I mean, before we get into pain, it's good to have it so we can work. One other thing is, do you have disk coverage? The one that gives you percentage of copy cover?
So the question is, do we have a test coverage?
Built into the IDE? Right now, no. It's just we only support basic unit testing frameworks like TestNG, JUnit, and such.
James, what about in our pipeline library? Is there?
I think there was the analytics that has SoloQ. I'm not sure.
No. Okay. So that could also go in the pipeline library, right? So as you run the build, you could get your coverage report coming out, and that could be a really interesting thing to add to the pipeline library, I think. We had a question back there.
So pretend that you design this as a hosted service. Pretend that we are masochists and we want to run the whole thing locally. Is that possible today? Or are these containers available to do that?
Yes. So this is all open source. I'm not sure if the registry that we build our containers into is publicly accessible or not. I think that was something that it wasn't public, so the binaries weren't publicly accessible. But I think we are making them publicly accessible sometime in the next couple of weeks. Yes, you could run it locally. We have a kind of like a 3-person team who pretty much work on running it. So the code is there, the binaries are there. Have we optimized for that? No, honestly, we've optimized for running it ourselves. But the code, this is all open source. I don't think there's anything that isn't open that you would need.
So to add to that, us in regulated industries would be very interested in an on-prem hosted system. That's basically what the last 3 people have.
Yep, absolutely. We understand that.
So
Yep.
you polish it and have it ready and then and put it under a service contract.
Yep, that's great to hear. Thank you.
Does Eclipse Che, does it support unique plugins from regular Eclipse?
So the question is, does Eclipse Che support any plugins?
No,
from
the
regular Eclipse?
Che plugin model and Eclipse IDE, classic IDE plugin model are completely different. So they are not really, you can't just take a piece of Eclipse IDE and run it as part of Che.
Can you make a wind-up tool to take that?
We kind of have that as a language server.
So I was going to say, what we've actually done is go the other way, right? So traditionally, IDEs all built their own plugins in their own unique way. And I think, we realized that probably wasn't particularly useful for anyone because is it really the thing that we want to compete on, like, the ecosystem of plugins? And so I think that's what the language server protocol offers. Yes, okay, we have to build new things for this, but it is a much, much better way to achieve that because it is something that, so Eclipse has language server protocol support, Che does, VS Code does, Atom does, Vi does, Vim does, etc. Right?
Orion has,
I don't know how many plugins, how many language servers there are in the, for VS Code available today, but it's thousands, right? So I think this is a better foundation. It's a shared foundation that we can all build plugins on top of. And yes, it means re-engineering some of the traditional Eclipse plugins or the traditional, Visual Studio plugins or whatever to work in this way. But I think the good thing is that we're not really seeing that as an impediment, right? People are building a lot of these things very, very fast. They're becoming popular. There are still lots more challenges to solve. The packaging challenge, right? Okay, yes, we have a standard protocol, but every single IDE has a different packaging system. So you build the same protocol, but then you have to package it once for each IDE, which is a pain in the neck. So, can we also produce a standardized packaging protocol? I don't know, my experience of this sort of thing is if you try and say everybody should adopt X's thing or everybody should adopt Y's thing, it doesn't work. If you say, here's a new thing, let's all build on top of this, I think you've got a better chance of adoption through the industry.
I mean, just to add, the Java language support that we have on Visual Studio Code and other editors is actually a mini Eclipse running as a language server. So it's possible to have Eclipse components run as a language server and tied into Che.
And I mean, the early work on the analytics language server protocol that we've been seeing, that was done in VS Code. I mean, we had it working in VS Code, so we were like, well, this is a good place for starting. It's going to work roughly the same, and it meant we could progress. So this really is pretty interoperable between all these different IDEs. One more question? Anyone else? No? If not, well, thank you very much for attending.